what is the operation of this mass spectrometer. Is that okay? So to simplify this lesson, I have broken down each part over here. So I have the vaporization chamber, I have the ionization chamber, I have the accelerated electric field, I have the magnetic field, and also I have the detector. Is that okay? So I'm going to explain what happens in each of this feature or this part regarding the mass spectrometer. Collectively, it can be summarized as the operation of the mass spectrometer. Is that okay? So now the first essential feature, that's the vaporization chamber. Over here, the sample that is to be analyzed is placed in the vaporization chamber and then it is heated. So once it heats, it converts the solid or liquid samples into gaseous atomic particles. So in the vaporization chamber, there is conversion of the sample, whether it is in a solid form or in a liquid form, into the gaseous form. Is that okay? So in the vaporization chamber, there is vaporization. Is that okay? And the vaporization is done as a result of heating whatever particle we have here into a gaseous form. So we are going to convert the solid or liquid sample into the gaseous atomic form. Is that okay? That is what happens in the vaporization chamber. Once we get the gaseous particles then move through this small opening here. The gaseous particles then move through the small opening over there into the next chamber. The next chamber is where we have the ionization chamber. So I have indicated here the second diagram, the chamber, that is the ionization chamber. In the ionization chamber, we have a positive electric plate, and directly opposite to this positive electric plate, we have a heated filament or heated coil. Is that okay? So the heated filament emits high-speed electrons. And don't forget that electrons are negatively charged. And directly opposite to this heated filament, we have a positive terminal. So the positive terminal attracts this high-speed electrons. Is that okay? So there is a constant attraction taking place over here. So we have indicated the dot over here, which represents the electrons moving in this direction towards the positive terminal. Is that okay? So this is what is going on in the ionization chamber. Then, the particles that are now in the gaseous form move into the ionization chamber. Once they get into the ionization chamber, these high-speed electrons knock off electrons out of these gaseous atomic particles to form positive ions. So once the particles, so these are coming from the vaporization chamber, the gaseous ions, once they get into the ionization chamber, the high-speed electrons are situated in such a way that they will bombard or they will collide with these gaseous particles. And then once the collision takes place, they knock off electron or an electron out of the gaseous atom. Is that okay? And don't forget that once an electron is knocked off the gaseous atom, it changes into an ion. It just becomes an ion because it has lost an electron. An electron has been knocked off out of it, so it becomes an ion. Is that okay? So, and don't forget that when an atom loses an electron, it forms a positively charged ion. Is that okay? So, the high-speed electron bombards with the gaseous atomic particles, and then they knock off electron out of the gaseous atomic particle to form a gaseous positive ion. Is that okay? So, I said in the ionization chamber, changes the gaseous atomic particles into positive ions by bombarding them with the high-speed electrons. That is what happens in the ionization chamber. Is that okay? Now, once the positive ions are formed, they then move into the next essential feature. That is what we call the electric field. Is that okay? That is what we call the electric field. The electric field attracts and accelerates these positive ions formed from the formed from the ionization chamber. Is that okay? So the electric field attracts and accelerates the positive ions once they get into that chamber. So over here, I have provides an electric force on the positive ions, causing them to accelerate. So it attracts the positive ions from the ionization chamber, and then it accelerates them. Is that okay? At a high speed. it accelerates all the positive ions at a high speed. Is that okay? So I've indicated here the accelerating electric field. It accelerates all the positive ions that was formed as a result of the bombardment with the high-speed electrons through the electric field. It accelerates all of them. It accelerates all the positive ions into the next essential feature. That is, so over here I've indicated arrows. The arrows indicate the acceleration of the ions. So these are the positive ions which are being accelerated. And then they accelerated onto the next essential feature. The next essential feature is the magnetic field. So this is the magnetic field. So this is the magnetic field I have here. That is the electromagnet creating the magnetic field in the instrument or so. So I have the simplified diagram here. So these are electromagnet which is creating the magnetic field here with the particles that are accelerated from the electric field. Is that okay? So in the magnetic field, what happens in the magnetic field is that it deflects these positive ions into semicircular parts. It deflects these positive ions into semicircular parts. So it deflects. Once the positive ions get into the magnetic field, they are deflected in semicircular parts. And the deflection is based on the mass of the positive ions, or simply the mass to charge ratio of the ions. Lighter masses will be deflected easier compared to the heavy masses. Is that okay? So in the magnetic field, it just deflects the positive ions according to their mass to charge ratio. Is that okay? It deflects these positive ions according to their mass to charge ratio onto what we call the detector, and that is the last essential feature of the mass spectrometer. It deflects the positive ions onto the detector. So I have the detector here, which I have broken it down into this form as well. So this is a detector. Is that okay? So in the detector, what happens over there? The detector detects the ions as they give up their charges in the form of electric current. The detector is also connected to a mass spectrum. So this is a detector. You can see that I have a line illustration here connected to something. This is the mass spectrum. Is that okay? The detector is connected to the mass spectrum. It is on the mass spectrum that is where the relative intensities or the analysis on the sample which is being investigated is displayed on the mass spectrum. The mass spectrum is just a graph of the relative intensities or the relative abundance against the mass to charge ratio of the ions. Is that okay? So first of all, the sample is placed in the vaporization chamber. It is converted into gaseous atomic particles by heating them. Is that okay? Once the gaseous atomic particles are formed, they then move into the ionization chamber. In the ionization chamber, they are bombarded with the high-speed electrons. Is that okay? They are bombarded by the high-speed electrons to knock off an electron from the gaseous atomic particles to form positive ions. These positive ions are then attracted and accelerated by the electric field. Is that okay? They are accelerated by the electric field onto the magnetic field. In the magnetic field, it deflects these positive ions according to their mass to charge ratio. The lighter particles or the lighter ions are deflected faster or more compared to the heavier ones. That will be deflected in a very slow way. Is that okay? And then the magnetic field deflect them and focus them onto the detector. The detector is where the relative intensities or the needed information we need about the positive ions are displayed on the mass spectrum. The mass spectrum is simply a graph of the relative intensities or the peak height against the mass to charge ratio. Is that okay? On the mass spectrum, we can read the mass of the positive ions on the x-axis directly. We can also know the relative abundance of the ion directly on the y-axis. Is that okay? On the mass spectrum also, we have what we call here peaks. Each peak represents an isotope. Each peak represents an isotope. So if an element has no isotope, only one peak will be drawn on the mass spectrum. Is that okay? only one peak will be drawn on the mass spectrum. So for example, the element that was analyzed here has 3 peaks. The 3 peaks indicates that we have 3 isotopes present in that element. Is that okay? That is the operation of the mass spectrometer. The mass spectrometer is used to determine the relative atomic mass of elements, the relative molecular mass. It is used to determine the number of isotopes present in an element as well. Is that okay? So that is the mass spectrometer. That is the mass spectrometer. So we need to know the essential features: the vaporization chamber, the ionization chamber, the accelerating electric field, the magnetic field, and then the detector. We need to know the operation of the mass spectrometer. First of all, the sample is placed in the vaporization chamber where it is heated, and then it converts, if it is a solid or liquid sample, into the gaseous atomic form. It then moves into the ionization chamber where it is bombarded with high-speed electrons to knock off an electron from the gaseous atomic particle to form positive ion. These positive ions are then attracted and accelerated by the electric field onto the magnetic field. The magnetic field then deflects these positive ions according to their mass to charge ratio. Lighter ions will be deflected easily compared to the heavier ones. So they are deflected in a semicircular path as indicated in the magnetic field region onto the detector. The detector detects the ions as they give up their charges in a form of electric current, which is connected to a mass spectrum which collects the relative intensities and relative abundance of the sample which is under investigation. So that is some generalized information from the mass spectrometer. Is that okay? That's the generalized ideology of the operation and essential features of the mass spectrometer. That is it for this lesson. If there is any question, you can let me know in the comment section, or any contribution, you can let me know in the comment section as well. Please don't forget to subscribe to our channel for more exciting lessons in chemistry.